Hello, on this video I'll be going over how to add in a capacitor to the Altium libraries that we use in Badgerloop. I'm not going to spend a lot of time editing this video down if I mess up, so just bear with me as we go through it. So let's get Altium started. So when you open Altium, helps to open up the pod for design workspace. And while that's going, so right now these are the components that should be added to the database, to the library. So we're going to start out with the C3216 capacitor. So I've got that pulled up here. And with a capacitor, there will be a couple different types of links. So the one that you might be more familiar with is the DigiKey link. So that is where you would actually go to buy the part at. And then this other link, we'll wait for the DigiKey one to open. The other link will be the part to the actual manufacturer website. Is my internet stupid? Nope. Okay, here we go. So if you haven't seen a specific component before, their website, especially for discrete components, a lot of times we just look at DigiKey, but this kind of has the overall information about the part. So what grade is it? What series is it? A lot of the sizing that can be important. And then just like the general electrical characteristics. So this will be kind of the same thing that you would see over on DigiKey if it wants to load. But then what the advantage of going to something like this is that you get these characteristic graphs. Different manufacturers have different ways of presenting this information. Some of them don't present it at all, which is kind of annoying. But TDK is really good. Tayo Yuden is a weird one, but it still has that information. Some of them, like AVX, they don't really provide a lot of this information. So that can be annoying and maybe something to consider if you actually need to go into this level of detail about your components. But yeah, so this just has different characteristics like ESR, so that's equivalent series resistance, and it's kind of nice. I like TDK a lot because the points on the graphs are very easy to find. You don't have to be like, oh well, that's probably 5, right here, 5 megahertz. You can just go right up to it and see that. DC bias, that's really important. Quick thing on DC bias, capacitors lose capacitance at when you have a DC voltage applied. So you can see here at 40 volts applied to this capacitor, it's gone down from 1 microfarad down to about half a microfarad. So something to consider if you need a lot of capacitance and you're running at a high voltage, you might need to get higher ratings of your capacitor or get multiple capacitors or increase your nominal capacitance in order to meet your overall capacitance need. Temperature characteristics, so that's something to look at. Usually for our range, which maybe is up to 50 C, maybe a little higher, we're usually pretty flat. But when you start getting up to temperature extremes, like 120 C, you can get 15% derating on your capacitor. So something to keep in mind, especially just like if your design has to work across this entire range. Sometimes they can be a pretty high fluctuation, in your capacitance level. Ripple temporizing is something that you have to be worried about if you've got like an AC signal, like the root mean square current going through the through your capacitor. So you get a temporize because of that equivalent series resistance. So something to keep in mind. You don't want to, if you're trying to push, 10 amps through this part, well, you're going to heat up a lot and you probably need to find a bigger package size. So we'll be referencing this sheet while we are working in our libraries. and then DigiKey. Oh, it still doesn't want to load, but you've all seen DigiKey before probably, so if you know what that looks like. So then looking in our design workspace, before we do anything, we want to open up Git Bash, and I've got the repo checked out already. We want to make sure that we're in the libraries branch. And then check that, we're just working with a clean copy. We've got it, all the way up to date. Yep, so we're all set. So now we can close that for now. And then now we're in, Altium. So I guess the first question is, why would you want to make a library component? And the main reason is if, say, your design requires a particular component, it doesn't have to just be a capacitor. It could be, a component like this, a power stage, could be, an inductor, could be really anything. We don't want to go in and edit this instance of a part and make that be, oh, this matches, I'm going to change all these values, change all the links. You don't really want to do that because then you would, you're only referencing that one part. And if I'm going to check it, then I'm going to, I might miss it. Or maybe you change your part on one, but not on the other. So you really want to be doing your, your work inside of libraries here. So there's a couple different types of libraries. The two main ones that we'll be working with are footprint libraries and schematic libraries. So these take a second to load, even in Altium 18, but it's better than it was in Altium 17 or previous versions. So if you look at here, there's a couple different, sorry, I want capacitor. So if you look here, these are kind of the different sizes of capacitors, so 0402, 0603, 0805, 1206 capacitor footprints. And you can see like they're bigger or smaller. These look about the same, but it's zooming in to fit that. So if you do like RP, measure your component, measure your sizes, measure the distance on a 1206, you've got about 50 mil. On a 0402, you've got, I'm doing RP, which is measure primitives. If you're interested in learning the Altium shortcuts, you've got about, sometimes these can be a pain. So you've got about 25 mil. So it is a different size for different components. And then if you want to clear your measurement, just for reference, it's Shift C. So that's fun. Yeah, so then looking at, you can have a lot more complicated footprints, capacitors, resistors, inductors. It's really just pads and solder mask and, your silk screen that goes on. So your pad, the red will be, the actual copper. So you can see like top layer, bottom layer, mechanical layer, top overlay, and then top solder. So those are the main layers that you're worried about. So top layer, you'll actually route, electrical signals out from the top layer and the bottom layer. Mechanical layers, you can see this kind of pink hashed outline, and that's where the actual like 3D component will sit. So we can look in the 3D viewer later on and see, yeah, we can't see, oh, can see in this view, we've got, I'm not using a mouse, so you can see like the 3D component actually sits on there. So then you've got your top overlay. So a lot of times on your circuit board, it'll be a green board, but then there will be, white lettering, white lines, white text, or, white circles or whatever. Basically just, it's for the user, for the person who's assembling the board to be able to tell like what's going on. You also see like the numbers, the reference designators that are associated with each part. That'll be in the silk screen. And then the top solder is kind of the layer. can think of it as like the layer that you will be kind of exposed to, and that will be kind of showing when you'll have exposed copper there. A little more nuanced than that, but for like a working knowledge, it's good looking at some of the other layers. So you can have a keep out zone, keep out layer. So that's an area you want to stay out of. You are there also can allocate courtyards. So that's basically a box that'll go around the component that says do not put any components in another component's box. So just kind of space allocation for no, you can overlap them usually, but you don't want to have those crossed because then your components will actually be crossed, and you want to avoid that. So I'm not going to get into how to edit one of these in this video. Hopefully in a future video be able to cover that. But then looking in our capacitor library, you can see that I've got a version control set up right now. So I've got green check marks and then this out of date capacitor library. So that's fine for this because I know what's out of date and it's fine. But you might want to check if you're seeing that symbol somewhere else. So now we're adding an 0402 capacitor. So one thing that's really helpful if you are doing a component that is very similar to a different component, it's to copy and paste that component rather than making a new one from scratch. So if we copy and we paste, then we'll get our second version of this component, and then we can edit the properties here. But the main advantage of doing this is that the fields will already be there, and it will already link the footprints. And it'll link the footprints and the 3D footprints to the actual schematic symbol. So it just saves you some time and maybe is a little less error prone. The thing you have to check out for if you're doing this is you have to make sure that you don't leave over, you replace all of the information and you don't like leave anything from the previous component. Otherwise, you might have a characteristic from a component that isn't valid for the component that you're actually using. So big thing in libraries, just double check, make sure you know what you're doing, and that everything that you do is backed up by something. So the main way that we want to edit this is via the properties window. So if we click on that and it wants to load, Altium does freeze every once in a while, so make sure you save often. There we go. Okay, so now we're seeing our library component here in the properties window, and we're going to, so one thing that we actually want to do is put the part number in the description side of things. And we want to put the, the actual, what are you going to search for in your library windows in the design item ID. So we'll call this a cap ceramic. So there's different types of capacitors. Cap stands for capacitor. Ceramic is CER. There's like tantalum capacitors. There's aluminum, aluminum polymer capacitors. There's aluminum electrolytic capacitors. There's a bunch of different types of capacitors. The main ones that we'll use on our boards are either going to be ceramic or tantalum capacitors. So usually you can just do that. You can tell, multi-layer ceramic chip capacitor. You'll see that abbreviated MLCC sometimes. And then we want to put in some, data about the component. So we know that this is a 1 microfarad. Yep, a 1 microfarad capacitor. Then we know that it's rated to 100 volts. And we also know that this is an X7R capacitor. X7R comes from there. And then we know that this is an 0402 package size. So we're going to put in 0402. We're going to leave our designator, our default designator, as C question mark. And basically what that means is when we import this into an actual design, after we've laid out all of our components on the design, we can say go to tools and then annotate schematic. And annotating the schematics will auto number all of your components for you. So C is like the default for capacitor, R is resistor, usually IC will be U, connectors might be J, test points is usually TP. So just some like standard, industry standard names for different components. We'll leave comment as equal to value. And then our description, as we did earlier, is the is the part number. Now, one cool thing that we want to try to do is add in supplier links. So this component is available on DigiKey, and we usually go to DigiKey as a default. Oh, this is a 1206. Whoops. That's why it's good to check, directly from the manufacturer. The components that you're using. So, whoops, I messed that up. Yeah, it's a 1206. So if you do want to change out your footprint, all you have to do is remove this, remove selected model, and then add in footprint, and then go to browse, and then go to the library you want to be in, capacitor 1206, bam, bam, bam. Now that's fixed. Yep. So then now we'll go back to our properties panel, and then we'll add in a link to the manufacturer. And from here, we will connect with the manufacturer and add that link in there so that, if you're clicking on a component, you want to say, hey, I want to know more information about this, you can go directly to the manufacturer. If you go back to the top of this window, if you look at the footprint, you can see the component footprints that's in there. So you can just tell that those are linked. And then for a model like this, the 3D is incorporated into the 2D footprint. But sometimes if you do your own step model, you might need to add in a separate footprint or a separate 3D component and get that connected in. Now we're going to look at the parameters tab. So the parameters tab is like the more detailed part information about the component. So this is where we'll go. At quantity, not super important for what we need. Data sheets, we will link in. This page is technically the component datasheet. You can download a PDF file if you wish. So we'll copy that over there. DigiKey part number. So then that gets copied over, automatically. Factory stock. It's always good to check out before you go to buy. So I think this one only had like 5 available. So we probably won't want to actually use this specific part in a design because, well, we can't buy it. So something to keep in mind. Image, that's something that, we don't really care about. If you wanted to, you could have one. But really, capacitors look pretty similar. We'll get rid of these. It's a TDK Corporation. We know we can buy these in ones from DigiKey. We know that it's a surface mount multi-layer ceramic capacitor. We know that the operating range from this chart is about negative 55 to 125C. Negative 55 down here, 120 there. So we can keep that the same. This is actually a 1206 capacitor. We'll always delete the metric version because who needs the metric system, am I right? Packaging, not super important for us because we're going to be laying these all down ourselves. If you have like a pick and place machine, then that might be important to go with. I'll copy over the part number. So one kind of important thing to look at, what is the status of the part? So this is a production part, so that means it's active. That means you can buy it. A lot of times there might be different, if you do a search, it might tell you different information for different parts. So you might have like a new part, so that's something that's just released. That might be kind of hard to find because sometimes DigiKey or Newark or Mauser might not have those parts yet. Active, that's where we usually want to be buying our parts from. That means it's been tested, it's currently in production, we should be able to find it. Then there's end of life, so that means that they're phasing out this design, so don't really put this in new designs. And then there's actually a not recommended for new designs status. And basically what that is don't put this in new designs. If you already have this in something and say you're a production house and you don't want to redesign it yet, then sure, keep buying it, but we should probably, get moving, away from this guy. So now looking a little bit more detailed at the parameters. So this is kind of the pulled in price to quantity. So one thing that you might have known already, or you might not, is that the more you buy, the less the individual cost is usually going to be. So you can see, if you just want one capacitor, that's going to cost you 60 cents. But if you want 1,000 of them, then they'll cost less than 20 cents a piece. So usually for stuff like this, we'll want to go in, order 10 or 100 of them because, it's cheaper. And then we'll be using these. Hopefully we can, agree on like a standard set of values and have those kind of in stock. So we don't have, in the Badgerloop stock, so that every time you want a capacitor, you don't have to, order one from DigiKey. We'll just have that on hand. So now we're almost done. We'll go through, not sure on the quantity available because DigiKey doesn't want to open for this. So the series is C313216. The size dimensions, we'll just get rid of that because we know, it's a 1206. Supplier 1 is DigiKey. Yep, that gives it to us. Temperature coefficients are there. Thickness, not super important for us, but we'll put in our height, 1.6 millimeters. Is that right? Yeah, 1.6 millimeters. If you could be doing designs where your board height is really important, say if you're like stacking components, you want to know, you might not only be limited, you might be limited to, a 2 mil clearance, or sometimes, I've worked on boards that we couldn't use this type of capacitor because it was too tall. We were limited to 1.5 millimeters. Actually, no, we were limited to 1.75, and you'll see that there's a tolerance of 0.2 mils. So at the highest band of the tolerance, we were out of our spec, so we couldn't use them. Kind of annoying, but what are you going to do? Find different components. So this one's also 10%. Unit price, unit price per one. We'll look, the great thing about looking here on the supplier information is that it has, actual, real-time values, or at least updated yesterday. So unit price, we'll spec out for tens, and then our value is going to be 1 microfarad. Voltage is set at 100 volts, and that's what we want. Yep, cool. If you want to add in more values, so we'll add in one more parameter, and we'll call this one bomb config, and we'll leave that one blank. So bomb config is for components that maybe we want to have in our design and in our schematics, but we don't actually want to put down. So a lot of times, if you're familiar with like a configuration resistor, sometimes we might want to connect up a circuit in different ways, depending on what we're doing. So for testing, we might want to have something connected, but maybe for the full production, we don't actually want to have this component. So we want to make sure to add in a bomb config to the library component and just leave that as open and kind of as default. We'll leave the bomb config at its default value, and then in the schematic we would want maybe that instance of the component to be a DNP, or do not populate. Otherwise we'll just leave that one as is. So now that we're done adding our part, we will save that. And once that's saved, I will show you how to work in the project. Cool. So now in the project, we've saved the library, and then now we'll go to, say, a new schematic sheet that just looks like this, or this could be an existing design. We've got this pre-church PCB project has this library mapped to us. It's the same library that is here. So this capacitor, you can see you've got the red change. So this capacitor is in both of these libraries. Once we have a really solid library, there's some things that we can do to compile these libraries and push it over into an integrated library. But for now, it's fine. So then we'll go to libraries, and then we'll go to capacitor. We want to make sure that we're one note on libraries. We want to make sure that we're using our own libraries and we're not using the miscellaneous devices and miscellaneous connectors libraries. The main reason for that is we don't know what those values are going to be, and we don't have any real control over it because we can't change the default Altium libraries. So you can see over in the libraries panel that I'm in my capacitor library, and here it is. The ceramic capacitor is right here. Now, say if I wanted to find, to kind of explain why we switched the design item ID and the library ID, is so that we can do searches by cap ceramic 1 microfarad 100 volts. And then you can type this through. You can imagine as our libraries become more and more full with new components, you can see you can kind of search the components that meet those requirements and then drag them in. So then when we've got our component, the one thing that we want to add, and this is something that is possible to do in the actual library component. So we want to change what we're displaying on the component. So we don't want to show the DigiKey part number, but we do want to show the package size and the voltage rating of your component. And then we'll put that in our design. So we're just making things visible and invisible here. We're not actually changing any of the component, quantities. Say if I were to hide 100 volts here, if I were to hide it, it's still a 100 volt capacitor, but we were just, we're just showing, we're just choosing what we want to show and what we don't want to show. So if I hide it, it's just invisible. I think that's fairly easy to grasp. So then the one other thing that we'll show in Altium right now is tools and then annotations and then annotate schematics quietly. So what this will do is say there's one designator requiring update, proceed with change, yes. So it auto numbers C1 and you can see like, okay, I could have just gone in and, typed it in myself, C1, how hard is that to do? But when you've got, dozens and dozens of components, you don't want any duplicate reference designators. It can be good to have individual, to have the tools do that for you. You want to make sure though that you're doing that pretty late in the game, because if you're adding in components and adding in values, then it can be really annoying if you've got like C1, C2, C5, C4, C7, out of order. So you want to just leave your components as the default question marks until you're ready to go in for that. So now I'm going to just delete this component because we don't need it for this design, and then I'm going to close without saving that schematic sheet. So now we've changed our capacitor. So now what's the next thing that we need to do? The next thing that we need to do is commit our changes. So you can see that I've modified the schematic library, so I'm going to commit it. And then one of the more important things to do when you're committing schematic libraries is say, these are the components that I added. And do git commit. Oh, whoops. Git add. So I just did a dumb thing where I tried to commit, but I didn't have anything added, so. So now I've committed, so you can see my branch is ahead of origin JS libraries by 1 commit. So I'm going to push these changes to GitHub. And now that I've pushed these changes, we'll go over to GitHub. We'll look in our libraries branch. You can see we've got our 1 commit changed, and then this component is fairly basic, so what I'm going to do is make a pull request. And then just make sure that you're committing what you want, and it's really important that we are committing, pushing, and making pull requests right away when we are making new components, because what that allows you to do is to access to these components that you're making in libraries inside of your other schematic designs. So for most of you who will be making library components, you won't be able to merge your own pull requests. You need someone else to look at it and review your pull request. So view the changes that you made before we put that into our master branch. So you can ask myself, you can ask Tristan, you can ask Vaughn, or anyone else who has some experience with Altium, and will want to do some checks of your components to make sure that they're valid. So for something like a capacitor, if you get a datasheet link wrong or you mess up you say, in a description that it's no 402, but it's actually, a 1206, like I did earlier, and you don't catch it, it's not the end of the world for something like a capacitor. But if you've got something like this, where you've got, 20 or 30 pins here, and you do something stupid, like you mix up VIN and switch node, or whatever you might mix up, or make a mistake here, your entire board could just be broken. So we want to make sure we're doing a good job of checking over all of our components, checking over all of our when you go into making design changes, making footprint changes, we'll want to look down. Usually at the bottom of the schematic, it will have the actual dimensions. A lot of information in data sheets that you should be looking at whenever you're doing a design. So here we go. So this will have the the actual dimensions that you want, and then this is actually the recommended PCB recommended PCB layout. So for a design like this, you want to make sure that you match this guy pretty exactly. So yep, so that's something that you'll want to do. So when you're done merging your pull, or when you've had someone else look at it, and you say merge pull request, I can merge my own pull requests. Usually try not to do that. Usually try to give someone else a look. But for something like this, for the sake of the video, merge the pull request. If you want to join the GitHub channel, that's always fun. So that basically just has the commits that are in there. And then you can see that, this is now in master. So if I go down and I'm going to go git checkout master, you can see that there have been changes to the master capacitor library, which is good because we've changed it. So it means that our changes actually worked. And then yep, so then if I'm doing work on a design, if I can look in here, now looking at Altium again, you can see that if I go into project and I go into my libraries, now the component that we created is here. So now that's kind of the main steps. The one thing that I didn't show is how to change the default text placement and the default parameters that are visible. You can do that fairly easily in the component properties window. But actually, I think that's actually changed from Altium 17 to 18, so I'll have to take a look at how to do that. But not the end of the world. Hopefully, you can get that fixed. Yeah, so that's kind of the main basic way to do the adding in schematics. One note about version control. The only thing you really want to do in this Altium version control is refresh, and then if there are conflicts, then we use the conflict resolution that Altium provides, but we don't want to be doing like version control commit whole project or commit or doing that. We want to be doing things from the command line because the way that Altium handles it isn't super great. So make sure that you're working, with a tool like Git Bash to do that sort of a thing. Great. If you have any questions, shoot me a DM on Slack. I think that's all I've got for this video. Thanks.